Oh, hang on, let everyone know they're recorded. Yeah, that's fine.
It's
click
recorded.
X.
Do you want me to just count those again to make sure we got it right? And
Wait a minute. John is double checking. Can you just do a drum roll? No pressure.
Get rid of it.
I can almost feel the stress coming from John.
yeah, it's 49.
49.
49.
Well done, mate. Thank you.
So the next one will be number 50,
Yay! Come roll on next March.
if that's important. But yeah.
Hello, everybody, and welcome to another E5 podcast. Well, that was an energetic start. My name is Paul Meenan. Thank you very much for listening or watching or whatever platform you're viewing or listening to. And I'm here with the most beautiful, talented, and competent tag team partners a man could wish for. Introduce yourself, lads.
Hello, I'm JW.
And it's David Watts here, Sparking Ninja.
John, the Wise Ward. And David, the Ninja Watts. There you go. I still am just Paul.
Just Paul?
I have no nickname or anything else. It's very strange. Don't really know what I can do.
That's it.
I was Sparky Jedi on Twitter, which I loved, but I don't do Twitter anymore. So, right. Today's going to be an interesting one because we have done a webinar. Because I'm assuming we've done the webinar. Yeah, we've done the webinar. I don't know.
Yes,
Let's cut this out.
Well, the webinar's this may or may not be this coming Tuesday when we're recording.
It may or may not be when we're recording this. So
we've done it by now. By the time you're hearing this.
By the time you're hearing this, we've done a webinar. There you go.
And it was long.
This is slightly different because one of the things I've always said, and I think I've said it in previous ones, to find out where you are today, you must know where you've come from. Whether that be you on an emotional level, an intelligence level, a personality level, family history, etc. And in this electrical industry, we have many debates and there's many arguments and many impassioned. Where did this wives' tale come from? And so we've been looking at the history of the wiring regulations for quite some time. And before COVID, I was doing some IET lectures for them, for Eng Tech and stuff. And to try and be different, I used to think, well, what can I look at that's different? And I managed to get hold of a copy of the original first edition of the wiring regulations, which was actually readable, which was great. One of the good things about being an IET volunteer, you can obtain these sorts of things. And so what we thought we'd do is we'd take you through this document and how actually it hasn't changed that much. So, yeah. That's what we're going to do. We'll take you through the history of the wiring regs, but we're going to concentrate in this podcast just on the very first edition. John, do you have any statistics for us when it comes to the wiring regulations?
Yeah, certainly do. Now, obviously, we're on the 18th edition at the moment, but that doesn't mean there's been 18 in the whole history of ever, because as anyone who's bought these things will know, a particular edition gets revised and there's an Amendment 1 and Amendment 2 and whatever. And before that, there were various revisions and supplements and all kinds of other bother. So since the very first edition in 1882, the number of actual books that's been published is actually 49. So that's quite a lot.
Without going too much onto a tangent, what is it that makes them change the edition at the time? Is there a limit on how many amendments they can make to an edition before they have to make it a next edition?
Yes.
There was, wasn't there? Yeah.
There is. So in BS0, which is the most original name ever, there is guidance in there that talks about a standard can be revised twice before it is then required to be an entirely new standard. However, you can do a third amendment, but you will just tell the BSI that you're doing a third amendment because it may not be sufficient change to warrant a full revision. So when we go to the 19th edition, the Wiring Regs Committee will be expected to do a complete revision, complete review of the entire content of that standard for the 19th edition.
Obviously, you're referring to BSO, which is fairly modern, but that kind of attitude or behaviour has probably gone back in time, really, when we went from the 12th to the 13th, or was it maybe due to engineering changes? Or
Well, glad you say that, actually. So, John, if you've got anything you want to add in here before I go off on my little history, please do.
The basically prior to about the 17th, it was sort of any old thing goes, really. Because, I mean, the 16th edition was a right mess, because the 16th edition actually had 3 different titles. Because they changed it from the Regulations for Electrical Installations, and it became BS 7671 1992, and then it also became BS 7671 2001, but it was all the 16th edition. And there was actually 9 of those, which is ridiculous.
Well, there were, I mean, it had a long life, the 16th edition.
Yeah, very long.
Very long life.
And the ones before that, most of the ones, it was basically, so like say the 13th edition, it was put out in, I say, 1955, and then there were some minor corrections, and then there were some amendments, and then there were some more amendments, and then there was some more. So it was just whoever was writing it at the time just changed some stuff. Oh, print a new book, print a new book. Yeah. So it was actually worse then than it is now. So in that particular one, and then you got a book published in 55, 58, another one in 58, 61, 62, and 64. So
some books, a couple of people were really enjoying writing books at that time.
Yeah.
Right?
So people complain today that, oh, there's a new book coming out all the time. Well, it's actually only about every 3 or 4 years. Yeah. I mean, that in that 1950s, you were buying one every other year, basically. So the idea of it being revised too often is definitely not a new one.
Okay.
So let's get on with it. So let's give you a little bit of history. So in the very beginning, and we've done a bit of research, and the earliest references to any sort of wiring rules and law is not 1882. You've got to go back in time further. 1847. So there was an act, as they called them back then, of the Parliament. I'm sure they were probably all wearing wigs and stuff, called the Town Improvement Clauses Act. And it's commonly known as the Gas Act. Why? Because before electricity was a common thing, we used to light cities and towns with gas. So it was an act for consolidating paving, draining, cleaning, lighting, and improving towns, because, you know, they had to do something about the sewers that were right outside people's windows, and, you know, having gas lights and explosions and all that good sort of stuff. So in 1847 was the first references to, you know, some sort of lighting or the future of where we were going to be with regards to acts and laws about keeping things in some sort of parliamentary act. But then on the 17th of May in 1871, fast forward a few years, this bloke called Sir Charles William Siemens, as we know Siemens now, who were massive. He was German born, lived in English. He was an engineer and an inventor, and he worked a lot in the steel and telegraph industries. And he was actually the very first president of the Society of Telegraph Engineers, which then became the Society of Telegraph Engineers and Electricians, which then became the Institute of Electrical Engineers. And what is fascinating is you can go online and you can buy these books. And what happened was they had regular meetings, and all the meetings, they would present white papers and theories. And there is actually one online where somebody talks about electrical earthing in relation to the electromagnetic field of the earth. And there is also stuff, and I think we've put snippets on our Instagram account, where the very first lightning protection system was a bloke with cast iron gutters that extended up past his house to help the smell go away. It got hit and managed to carry the lightning down, and it was recommended that this cast iron gutter was maybe used as a method of protecting buildings in remote areas from lightning. So this is all the way back in, you know, the 1870s odd. So Sir Charles William Siemens, obviously, he decided to do some experimenting in a place, and I'll never get this name right, in Godalming in Surrey. In 1881, basically, it became the very first town in the world to have a public electricity supply. Okay, and basically he put in this Siemens AC alternator and dynamo. We know dynamos nowadays as motors, generators, but in them days it was a dynamo, not the magician, just a dynamo motor, which were powered by water wheels. So he built this basically motor next to the waterway. He run a number of supply cables that were laid in gutters. Madness. And he put in 34 incandescent lights. But in 1881, floods caused loads of problems. There was loads of issues with it, and eventually in 1884 the whole town said, poke your electric lights, we're going back to gas. But that was the very, very first trials of electricity in what we now know is the norm.
And I guess at the time when they probably moved from gas to electricity, the users locally didn't probably see a huge significance with regards to the light levels achieved by gas to electricity.
Magic.
You know?
It's magic. And
they probably just saw all these cables shorting out.
Well, you think about in the homes them days, they were used to the flame. Their eyes were used to the flame of their fires and the lights outside. You've now gone with this bright, intense electricity. Oh no, we don't like that. You put the gas lighting man out of a job.
I mean, it's just an incandescent. Probably a big contrast of light, though. Probably.
Yeah, more than likely. Obviously, I wasn't alive in them days, but yes, there's no colour photos and the photo quality isn't great. But yeah, so in 1872, he became the very first president of the IET. So it's very relevant. But in 1875, that Gas Act, as we remember, we spoke about earlier on, became the Public Health Act. And the Public Health Act was designed to properly start cleaning up towns because they were just foul, horrible, stinky, nasty places to live. You're introducing gas, you're introducing electricity. I'm sure there was mass murders and killings going on from people not installing this stuff correctly. And then eventually in 1882, what we now know as the Electricity at Work regulations, or not the Electricity at Work regulations, the ESQCR. So the Electricity Supply Quality Continuity regulations. In 1882, the Electric Lighting Clauses Act came out because they had all these magic electric lights. There had to be some sort of act of parliament that controlled and, managed it in some form and made sure it was safe. This actually went on to become the Electricity Supply Regulations, amended many times. And then in 2002, if I remember rightly, it became the ESQCR when it all got, it just all went downhill really from there, I think.
Again, this is all way before any kind of grid idea and all that stuff at the time.
It was always local generation.
Yeah,
and me and John have looked at books where you've got adverts for very rich, well-to-do people who were encouraged to have dynamos in their home and wiring for those rich elitists, obviously, which we don't fall into, but that's what happened. Anyway,
it's very much if you were rich, you had your own personal private generating equipment and your own personal stuff, and then you could light up your house and say boo to all your neighbours. So.
Yeah, hang on a minute, chaps. Isn't that what we're heading to now with prosumers?
We may be, again, we may be in 20, 25 years' time in that position where at a certain time of night, some people are still lit up because they've got the storage on board or the generation capacity, while some of us may not yet.
So years ago, in the 1870s, you had dynamos, motors generating and using water from rivers and stuff to generate electricity to run public lighting. 2021, we have solar on the roof, generating power to a battery storage. Similar principle, just no moving parts. So we haven't really changed in hundreds of years. But let's move on a bit. 1880, the Society of Telegraph Engineers and of Electricians was formed. So the telegraph engineers finally realised they couldn't do it without sparks. And in the general meeting of the Society of Telegraph Engineers, 22nd December, it was decided to alter the title to reflect changes in electrical technology, and it was renamed Society of Telegraph Engineers and Electricians. Then in 1887, a motion was put forward, and you can read all of these if you go online and find the books with the papers in it, to alter the name to the Institute of Electrical Engineers to represent the body of electrical engineers in England. And then in 1889, the Joint Register of Stock Companies issued a certificate to incorporate the IEE. May 11th, 1882 is a date that a lot of electricians may want to remember. In fact, if anything, May 11th should be the annual Sparks Day. Why? Because on May 11th, the rules and regulations for the prevention of fire risks arising from electric lighting came about. So we went from that Public Lighting Act into a more detailed set of guidance specific for the installers. We know it as the first edition. And what I've always found fascinating about this is the title, because it says rules and regulations.
Yeah.
Is there a massive difference? But more importantly, prevention of fire risk from electric. 2021, we're still not getting it right because we still have electric fires. So it was made up of 21 regulations. Basically, it was a little A5 foldable thing, or an A4 sheet that you just folded up. And these were handed out when people would turn up to the Society of Telegraph Engineers and Electricians. These were handed out as printed papers. This is how they got them. Luckily, some have survived and they've been scanned. But it was 21 regulations and divided into 4 parts. Okay, so we're going to go through those 4 parts. But before we do, Dave, do you want to just take us through the preamble of in the beginning? There's a little bit of narrative, like an introduction that we have nowadays.
Okay, it's got here, in the beginning, these rules and regulations are drawn up not only for the guidance and instruction of those who have electric lighting apparatus installed on their premises, but for the reduction to a minimum of those risks of fire, which are inherent to every system of artificial illumination.
Interesting though, isn't it? 1882, guidance, instruction, very clear defined rules and regulations to risk of fire, and artificial illumination, because it was an early technology, quite high risk of fire. It then obviously goes on to say about the chief dangers of every new application of electricity, and I love this, are from ignorance and inexperience on the part of those who supply and fit the plant. So the first edition,
that's great wording,
openly says the danger is you may be basically ignorant and incompetent. Now it doesn't say that, it says inexperience, but inexperience could be defined as a lack of competency.
Oh, yeah.
Of the installer. That's mind-blowing stuff, chaps. It really is when you think about it. First edition warns of incompetence. The current edition doesn't really reference competence much other than for testing. You're now skilled or instructed.
And it still doesn't touch too much on the actual ability for you to, again, be ignorant with that. Doesn't really in any way assume that of you.
Yeah.
Where we define competency today.
John, what else does it say?
Right, we've got the difficulties that beset the electrical engineer are chiefly internal and invisible, and they can only be effectually guarded against by testing or probing with electric currents. They depend chiefly on leakage, undue resistance in the conductor, and bad joints, which lead to waste of energy and the production of heat.
Hang on a minute, John. What you've just told me before we've even got into a regulation, we're talking about testing, using probes. We're talking about earth leakage. And by the way, some electricians in 2021 are just coming to the concept of earth leakage, and we're talking about leakage in 1882.
I also love the mention of the waste of energy in there.
Energy efficiency in 1882.
To consider the ability to abuse and waste energy back then.
1882, guys. It's fascinating because, and the reason why we're doing this as well, it's worth noting, is sometimes people go, well, the old regs are the old regs. Not necessarily, because a lot of people go, well, that was to a previous edition and the previous editions were substandard. This is the first edition and it's still relevant today, if anything more relevant. So it also talks about the defects that can appear in any electrical installation can be detected by measuring by means of a special apparatus. Yeah, the currents that are either ordinarily or for the purpose of testing. So we would inject currents in the old days. We don't do that anymore in the same context of what they did years ago, but we still test.
Which we
pass
did.
Through the circuit. Bare or exposed conductors should always be within visual inspection. Oh my God, inspection. It talks about inspection. Since the accidental falling onto or the thoughtless placing of other conducting bodies upon such conductors might lead to short circuiting or the sudden generation of heat to a powerful current of electricity in conductors too small to carry it. My mind is blown.
See, thoughtless placing of other conducting bodies is, again, such a good way to kind of describe it.
But they did. They would run bare conductors on porcelain pots, and it was very crude and rudimentary in them days. But I like the fact that it talks about inspection. It talks about testing. accidental falling on it, external influences, consideration of short circuits and the heat generated by them.
Let me just quickly jump out of this a moment.
Go on.
All right, if I'm listening to this, right, I've got my MFT, I've got my battery-powered, I don't know, QTech Mega Fluke. What would they have had back then? We talk about, you know, what instrumentation? Because it says the tests. You know, this is something I want to look at next. I mean,
I think
we know the wind-up and the dynamos and stuff were used, but how far back do they go?
I do have a book.
Yeah,
It was published in, I think it was 1890s. It's American, but it's a whole book on inspection and testing and wiring in America, which is quite interesting. I'll have to read it.
it'd be really interesting to see what kind of instrumentation they still had back then. Instrumentation is not new.
No, none of it is. It's just I love the narrative that they use in this, but we'll move on as well, because it then says it cannot be too strongly urged that amongst the chief enemies to be guarded are the presence of moisture. Hello, external influences. Where have you been all my life? And the use of earth as part of the circuit. What an amazing way of saying earth is the enemy of the line and neutral conductor.
This is just the way they worded things back then, and they have fantastic fonts with these kind of things as well, and all the warning notices. We've seen chief danger used. Now we're seeing chief enemies used.
Yeah. But also and I love this this is just the opening narrative, the preamble to the regulations. It says the chief element of safety is the employment of skilled and experienced electricians to supervise the work. Mind blown.
Skilled and it's like we've just gone back to that now, because we're really now talking about persons who are skilled, relevant to the nature of the work to prevent danger right now. Yeah, it's the closest our definitions have been to the original ones.
Yep, and it is in there, by the way. We've not just made that up. It is in the first edition, just before we get to part 1 on the dynamo. So obviously dynamos, big, huge, clunky motors, generators. So I'm going to take you through them. Now, I want you guys to say, what are the rubbish? And what we'll do is we'll swap them around. So let me go first. Regulation 1 of the first edition. The dynamo machine, or motor, generator, should be fixed in a dry place.
Yeah.
Is that relevant to today?
Yeah.
External influences?
Yeah.
IP ratings? Come a long way, baby.
But, again,
but
how do we define a dry place today?
There'd probably be a guidance note just on that, to be honest with you.
Yeah.
Lacking the presence of certain amount of moisture.
Would we not overcomplicate that?
I think we probably could.
Yeah.
But let me take you on that journey, because we're not feeling confident and warm and fluffy. It's very common sense. So rule 2 of the first edition, it should not be exposed to dust or flyings.
Flyings.
Now, I don't know what flyings is. I'm assuming that's just
that's some kind of debris of machinery or
bits
something.
of debris. Yeah.
And stuff,
So this is about protection of the dynamo machine, the motor, the generator. It should not be exposed to dust. So basically, put it somewhere where you're not got flour stored and moisture and all that sort of good stuff. Keep it clean, keep it safe, keep it tidy. Very relevant to today's external influences. And that's just one line. The next one, it should be kept perfectly clean, David and John, perfectly clean, and its bearings well oiled. So you got to service the machine and keep it clean. I mean, come on.
Perfectly clean.
Perfectly clean, dear boy. What? Number 4, and this is the first reference to insulation as well. The insulation of its coils and conductors should be perfect. So this is painting a picture of a quality install, nice and safe, considering the external influences. This is relevant to today's stuff.
But it's indirectly forcing better workmanship than what we have today.
Yes, because
today it's so much about knowledge, but not the actual produced output.
So if Mr. Skirn was here, he would talk to you about now that the current regulations and current standards landscape is output based. It's very much not prescriptive, but output based. So rather than say you will, you shall, you must, it will kind of fluffily talk around the performance or the output requirement, which I think is where standards have gone so downhill. and that was purely cost-cutting type exercise.
Yeah.
But we go into regulation 5. It is better when practicable to fix it on an insulating bed.
Okay.
So this is the motor. Put it on an insulating bed.
We have the word practicable. It's the first time I've heard this now. What do you think practicable would have been considered as back then?
I have a really weird feeling that given the way law is, it's probably the same thing. If it's possible to do it, do it.
So so it'd just be again a case of risk or cost?
Well, I don't. At them days, you'd just be rich. I think it's if the floor conditions allow it.
Okay.
I would assume that as. Moving on, all conductors in the dynamo room or motor room should be firmly supported. Oh my God! Well insulated, conveniently arranged for inspection, and marked or numbered. So regulation 6 of the first edition is better than most parts of 7671. Because let's be honest about it, if you put that in the current regs and said all conductors should be firmly supported, tick, premature collapse, well insulated, yeah, double insulated or whatever you need depending on the installation, conveniently arranged, not lashed in like some sort of children's shoe drawer where everything's all knotted together, and arranged for inspection and marked and numbered. Hello, you've got a lovely installation.
I would love to take some time somewhere, look for history as to what was meant by conveniently arranged, to see what they if that is what it sounds like, just make sure that they're all well ordered and nothing's crossing over, nothing's confusing, which we see so much today. I'd love to try and get that put back in.
John, what's your thoughts on conveniently arranged?
I've got certain books with pictures of stuff in, and it's literally perfect in every way. So you've got like a great load of conductors come down, and they're all exactly in line. And if there's a bend in them, all the conductors all got the same bend in each one, and huge amount of skill went into that.
So conveniently arranged is now, in modern times, a well-dressed board.
Yeah,
that's about as good as it gets. When it goes into a bit of 6x6 trunking, all bets are off. Because that takes way too much time. The one thing I do like is when the data installers, when they get a bit of ply and they drill holes, and then they'll do a cable comb on the Cat 6s. That to me is conveniently arranged, where they're dressing it in so that nothing crosses over, and that to me is conveniently arranged.
Fundamentally, for me, conveniently arranged would mean that if you're going to do some inspection work or some modifications or some work beside it, it's easy to work with, easy to identify cables, easy to identify the runs. We don't really have anything in 7671 that really we can highlight for that, other than just workmanship.
Yeah, I agree. So moving on, so regulation 6 is now officially my favourite reg of the first edition. But let's move to number 7 because we're nearly through them. Amazingly, every switch or commutator used for turning the current on or off should be constructed so when it is moved and left to itself, it cannot permit of a permanent arc or of heating, and its stand should be made of slate, stoneware, or an incombustible substance. So this is probably the first reference to isolation, but under two different guises. Isolation from the building fabric, which is 421, 422, thermal effects of heating other parts of the building, which we did in our thatch building podcast, but also the first references to when you're disconnecting and separating the conductors, try and make sure you don't have an arc. So it's a double reference for isolation, which is mind-blowing. 1882, everybody.
It works, so doesn't it?
There should be, in connection with the main circuit, this is regulation 8, a safety fuse constructed of easily fusible metal, which would be melted if the current attained any undue magnitude and would thus cause the circuit to be broken. So that's a really complex way of saying stick a fuse in it with something inside that will just pop.
Yeah, put a weak link in. Stop the cable melting.
So John, regulation 9, go for it.
Yeah, number 9 is every part of the circuit should be so determined that the gauge of wire to be used is properly proportioned to the currents it will have to carry, and changes of circuit from a larger to a smaller conductor should be sufficiently protected with suitable safety fuses so that no portion of the conductor should ever be allowed to attain a temperature exceeding 150 degrees Fahrenheit.
Fahrenheit.
Yeah.
What's that in degrees?
It's not far off.
It's 66 degrees Celsius or centigrade.
Yeah, it's not far.
That's not too far off then.
Pretty near 70, yeah.
Yeah, okay, there you go. So there's another challenge. Why has that changed? Well, probably technology and understanding of it. But there's a note, John, on that as well, isn't there? Little NB note that they've put after the regulation.
Yeah, we've got these fuses are of the very essence of safety. They should always be enclosed in incombustible cases. Even if wires become perceptibly warmed by the ordinary current, it is a proof that they are too small for the work they have to do and that they ought to be replaced by larger wires.
Whoa. Stop. Time out. Hang on a minute. Whoa. 1882, enclosed in incombustible cases. Wasn't there this huge hoo-ha when Amendment 3 came out about metal fuse boards? But yeah, in 1882, incombustible. Hello? And it was probably asbestos.
What's the problem back then?
Yeah. Well, it evidently was. But what I find amazing is even when you go to a manufacturer, say my circuit breakers are getting warm, Dave, grouping, thermal dissipation, this says it is proof that they're too small for the work they have to do. There's one for your thermography, Mr. Watts.
Again, is there anything in 7671 that talks about the actual thermal temperatures of the protected devices?
No, but there was in 1882.
Because we've said so much about the fact that it's all about electric shock and not about thermal.
Yeah.
You know.
Yeah.
It's madness, isn't it?
Most of what's in there. Yeah, most of what's in there now is just obsessed with the conductors. Yeah. Not the things on the ends of them.
Not the device temperatures.
Well, because the manufacturers don't want you talking about their devices.
Yeah.
Well, no, because then it shows you their weaknesses when you have them under those higher temperatures.
Anyone can make a fuse wire. It takes another kind of man to make an MCB or an LCBO.
Right. Do you want me to read number 10?
Yeah, go for it.
All right. So, rule number 10: under ordinary circumstances, complete metallic circuits should be used, and the employment of gas or water pipes as conductors for the purpose of completing the circuit should be in no case allowed.
So basically, what that tells me is some fool at some point would probably run a wire, connect it onto a water pipe, and then pick it up somewhere else, which probably killed God knows how many plumbers in 1882.
Yeah, but some houses today may have that simplicity for their neutrals.
The fact that they put fact that they put this in the first edition, you know somebody's died from this sort of experimentation. And if you do get the old books, which are available on Amazon and eBay and stuff, where they put all the notes in a big thick book, you can read some of the humor and of how they would willingly experiment on various things to understand electricity. But yeah, that's a weird one. Anyway, carry on. Sorry, Dave.
All right, number 11. Where a bare wire out of doors rests on insulating supports, it should be coated with insulating material, such as India rubber, tape, or tube, for at least 2 feet on each side of the support.
That's interesting. So it allowed you to run bare conductors, but where it came into a basically these were like porcelain pots that you'd tie the cables to, and they'd sit off of the building material. And what they're basically saying is
2 feet.
For 2 feet either side, insulate it. Now we wouldn't dare do that.
I guess that must be a consideration of arm's reach to the person going there.
Yeah.
Would it be? Or would there be a thermal reason?
Yeah, it's going to be partly probably for, say, reaching it, and also things like if it rains, you're not going to have tracking between the wires and the whatever it's attached to on the insulator.
Right. Well, we'll go on to 12 and 13. We're nearly there. Bare wires passing over the tops of houses should never be less than 7 feet clear of any part of the roof, and they should invariably be high enough when crossing thoroughfares to allow fire escapes to pass under them. Now, I know for a fact I've seen buildings where they're TT and they are literally sagging across roofs. This is in 1882. They didn't want bare wires doing it, but what the DNOs now do, where they find that, they get like these plastic sleeves that they put over the wires just to prevent any arcing incidents.
Yeah. And then when they've been up there for 10 years, they go brittle in the sun and crumble and fall off. So
I was going to say, they're not good for long life in the sun,
I'm suggesting that these aren't under a rigorous inspection and maintenance regime, John. Of course they're not. Anyway, sorry, apologies. On the next one, number 13. So it is essential, and this is one of the brilliant ones as well. It is essential that the joints should be electrically and mechanically perfect.
I love this word, perfect.
Perfect is beautiful. One of the best joints is shown in the annex sketch. So they actually put a drawing in the first edition. The joint is whipped around with small wire and the whole mechanically united by solder. So you basically twist everything around and then you coat it in solder. That's deemed a electrically and mechanically perfect joint. It would be great if the 7671 actually showed how to do crimps and terminations and all that sort of good stuff. Wouldn't it be great if they did that? Just an idea.
Yeah.
Might educate people a bit more. John, number 14.
The position of wires when underground should be efficiently indicated, and they should be laid down so as to be easily inspected and repaired. And this is more than likely going to be putting it in ducting and having access covers in appropriate places, not just getting your cable and slinging it in the ground and covering it up. And efficiently indicated, so you're going to have markers, probably terracotta posts, little indicator things to show where the cables are.
But that's it. I mean, they're talking about indicating it for ease of inspection right at the very beginning.
1882. Do you know how over the years how many people I've seen argue over what's the depth you need to bury a cable? And I just think this is a better regulation. The position when underground should be efficiently indicated. They should be laid down so as to be easily inspected and repaired. Not probably practical anymore, but I'd love them to slip perfect. The depth should be perfect. The cable should be suitable and perfect for being buried. That would be nice. But 1882, you know, these regulations were, again, all common sense, great rules, great instruction. 15, John?
Yeah, all wires used for indoor purposes should be efficiently insulated.
Okay, now look, by saying efficiently insulated, does that not hand over some responsibility to the person to actually determine what efficient means?
Wait a minute. Are we having an argument over the first edition of the wiring rigs here?
No, I'm just saying that wording, if we had that wording today, that puts an awful lot of extra work on the electrician to understand what they're doing. Instead of this doing the minimum, or
I think that's just
selecting a cable that we have available.
Dave,
I love that wording.
You could look at that and think that's chucking a load of loft insulation over it, although it'd probably catch fire very, very quickly, because you've misinterpreted another regulation earlier on that we just mentioned. But no, yeah, I think that is just basically efficiently insulated is what it is. I think it's just don't be a twat and actually insulate the cables properly. And obviously don't lay building fabric and all that sort of stuff. Okay. Yeah. 16.
Okay, right. When these wires pass through roofs, floors, walls, or partitions, or where they cross or are liable to touch metallic masses like iron girders or pipes, they should be thoroughly protected from abrasion with each other or with metallic masses by suitable additional coverings. And where they are liable to abrasion from any cause or the depredations of rats or mice, they should be efficiently encased in some hard material. Position of wires and underground should be efficiently indicated, and they should be laid down so as to be easily inspected and repaired.
Well, I think we should just pack up and stop now, because how many arguments, how many rows, how many bits of feedback. I get slated for putting conduit over my twin and earth cables in the walls.
Yeah.
Okay. Thoroughly protected from abrasion by what? Bricks? Yes. Passing through the wall where the wall can, subside and crack and damage the cable? Yes. John, didn't we talk about rats and mice living in lofts?
Yeah, absolutely.
So this covers thatched buildings, which in 1882 would have been frigging everywhere. They should be encased in some hard material. Yeah, put it in conduit. Everything in houses. Anyone who's worked doing house bashing, if you've come into London or Sheffield, whatever, you'll lift up boards in some old granny's house and there'll be this beautiful imperial black conduit with all junction boxes where they've cut away the joists, and it's a work of art under the floor, and they've just chucked singles in. This is perfect. You don't get any depredation of rats or mice. They're efficiently encased in a hard material. Why don't we do it anymore? Time.
Time, cost.
Yeah.
Yeah.
Cost mostly.
So the
'cause
workmanship stuff is just getting pumped out the regs. Other than a good workmanship material should be used. Why can't we put this? Because I would love to see in the regulations when you penetrate a wall, you will sleeve it to protect the cable, to protect the wall from any cracks or anything like that. Why not?
that's a thing that the American regulations have a lot more of
Yeah.
compared to what we've got, because the
Really?
American one,
Well-
the NEC, has a lot of stuff in like that, saying you will do this, you will do that, you will put outlets on a certain spacing, and
This comes
all that
back
kind of
to,
thing.
as like Paul said with Paul earlier, you will, you it doesn't give you, you shall, you will, you know, in these
Yeah.
in our book now.
Performance based rather than
Whilst in the
prescriptive.
States you get so much more of those instructions. That's more of a rules book.
America. Just got to throw that in.
But isn't it actually called the NEC rules, isn't it?
NEC rules, yeah. I think it is, yeah.
Yeah. Yeah.
So I love the fact that they can be easily inspected and repaired. How many times in 16 regulations have we mentioned the word inspected, tested, perfect?
Perfect. Yeah.
Perfect. You can see why people would hate this regulation now. But I see this as 1882, what is it, 136, 137 years old, all very relevant still to this day. I'll take you on the next one. So the next one is a little, it's a regulation that says where wires are put out of sight. Oh no, hang on. Yeah, there's put out of sight. They should be thoroughly protected from mechanical injury. It's interesting. Didn't I just mention we put steel conduits under the floor? And their position should be indicated. But then there's a note, and this note is brilliant, and it's one of my favorite parts of it. It says, note, the value of frequently testing the wires cannot be too strongly urged. It is an operation, skill in which is easily acquired and applied. Now, in them days, I don't think testing is an easily acquired. It's quite a bit of work to do. But where were we? Sorry, yes, easily acquired and applied. Then it goes on to say the escape of electricity. The escape of electricity. What an amazing phrase. Cannot be detected by the sense of smell, as can gas. A little bit of a dig at the gas industry there. But it can be detected by apparatus far more certain and delicate. Leakage not only means waste, energy efficiency again, but in the presence of moisture, external influences, it means destruction of the conductor and its insulating coverage by electric action. Holy shit. That note has covered inspection and testing, skills, talks about gas, how dangerous it is, leakage, energy efficiency, external influences in one note.
Yeah, it's really. I like that a lot. It actually kind of stands up for it as well. I like the little gas poke. I do like that. I also like the fact. I mean, as you say, it's where wires are put out of sight.
Yeah,
such as beneath flooring. I mean, we have so many cables buried, even like cables buried in the wall today, where there's an assumption that the zonal pattern is sufficient. But like we had on another previous podcast where we talked about the users expecting a level of service, if we need to start thinking about, should we draw or put a schematic or a plan drawing of the cable routing in the walls for the life of the installation to protect the occupiers of a home?
I don't know about you, John,
you know,
but when I was doing house bashing many years ago, I remember lifting up floors and the sparks would mark on the floorboards the routing.
Yeah.
They would do that. Don't get any more.
No, you don't get any more.
No, but it's so easy to do, isn't it? Just get a pen, pencil, or whatever, and
Steady on, John.
How easy with, especially with like modern devices, phones, just take some pictures and mark them and hand them to the customer or hand them to whoever you're handing the work with, so they have evidence of where the wiring is.
Yeah.
So many of these regulations are all about, that we have these days with RCDs and stuff pushing more and more because we have carelessness by use, and we have people penetrating the cable in the wall that's outside of a zone of some form. If we pushed the need to actually document the wiring positions, or we tightened up on the routing in some respect, so they shall only go down or they shall only go up within a certain height or depth, then the client gets better protection that way.
Well, let's go on to Regulation 18, John.
Okay. arc lamps, which was the main thing at the time, should always be guarded by proper lanterns to prevent danger from falling incandescent pieces of carbon and from ascending sparks. Their globe should be protected with wire netting.
Now this is interesting because I used to go to Northern Ireland every August when I was a kid for the whole month. That's why I had my birthday. And my granny lived in a little cottage, and she had an old oil arc lamp, and it would light up the whole cottage. Well, when I say the whole cottage, the room it was in, but she never had to touch it. She would, you'd pump it up, you'd light it, and it would just burn. And eventually, over time, little bits of carbon would fall. It was like a mesh, and it would just fall down onto the wooden surface of the sideboard where it was, and eventually just extinguish itself because it had just fallen apart. The heat had broke it down over time. And it's really interesting reading that one, but that's what happened in them days, where you would get bits of the carbon and the filaments of the light just breaking down from the heat and the overuse. And bulbs didn't used to last very long. So I just think that's a really interesting one, because it kind of goes about protecting the building fabric and isolating the hot parts from the not hot parts of the...
Well, yeah. And we have similar to that now. We have that with... in chapter 42, where luminaires may have control gear that heats up and can then be ejected from the fitting in a locate, but we only put that in the locations with stored combustible materials or made of constructional combustible materials. So we don't put that in general application.
John's now going to tell us the old equivalent of chapter 42, John, 19.
Yep. The lanterns and all parts which are to be handled should be insulated from the circuit. So there's your class 2 equipment.
It's a class 2.
So...
there you go. It's amazing, isn't it? 130 odd years old, and it it's not very different. Right, I'm going to cover the last two. Okay. So we've got the next one: to secure persons from danger inside buildings, it is essential so to arrange the conductors and fittings that no one can be exposed to the shocks of alternating currents exceeding 60 volts. And that there should never be a difference of potential of more than 200 volts between any 2 points in the same room. I'd love to know where they got that from.
I should imagine the test data. I mean, the data we look at today is not as old as this, so maybe they had their own data.
Mate, I could tell you now, I've got a report which talks about deaths from electricity. And it says that deaths from electricity are nothing like the railways, which is basically, and it calls the railways mass murderers for the amount of people they were killing in the early days of the railway. And it actually compares the electrical industry, which were murdering less people. So this is a good thing. I think I'll put it on our Instagram. I put a screenshot and put it on Instagram. Last one, if the difference of potential within any house exceeds 200 volts, whether the source of electricity be external or internal, the house should be provided outside with a switch, so arranged that the supply of electricity can be at once cut off. Fireman switch, anyone? Main isolator. Mind blowing.
Yeah, that is it. Yeah. So that's how you remove the potential. Yeah. Wonder where this 200 volts came from. We have to look into that.
Probably because the dynamos were only capable at that time of getting up to 200 volts.
Yeah. Yeah, it might be to do with the insulation types and things. It may have broke down, or say was some person got killed and it was slightly more than 200, and they thought that was a dangerous level.
Well, you
never know. You never could have gone on.
I mean, saying that back then, the nominal voltage for the street lighting may have varied from one generator to the next.
Well, they laid the street wiring gutters, so
yeah. So
God knows how those cables stood up to anything. But I'm not surprised the people in that Godalming said, "No, do one, poke it. We'll go back to gas." But
just imagine all these bad things happening, and then obviously, then most of these would have come out of some major disaster or people getting injured, killed, etc. So
yes, and I'll be honest with you, we could probably do 5 to 10 hours of podcasts just on old white papers that were produced on experiments with electricity and all sorts of shenanigans. But we're not going to. I think it's fair to say that for a document published in 1882, there's a hell of a lot relevant still to this very day. So if people say, where'd you get that rubbish from? You can actually quote the first edition on Wire and Regs. There's nothing stopping you.
Well, that's a good point, because so many people can look at the first regulations or rules and go, well, that's history, ancient history. If you understand the current regulations and then you understand these, you can actually say it's been here for over 100 years.
Yeah, absolutely.
You know, this methodology, this idea, this intent has always been here.
I will tell you now, there was a court case that went on. I spoke to someone at the IET about this. There was a court case that went on and involving an electrician, and the electrician went up and was arguing in his defence. And the judge at the time, I'm trying to remember this desperately, the judge at the time turned around and said, how long has this what you're accused of been in the wiring regulations? And the guy said it's brand new. And the prosecutor said, no, actually, it was in the first edition of the wiring regs. It's always been a requirement, which is 136 years old. And that's the thing. The judge will listen to that and go, not new then. I mean, we've just spoke about generators in homes, but now everybody's going, oh, we've got to discover the prosumer. No, 136 years ago, we were prosuming. We were generating, we were consuming, we were doing it very badly and burning lots of house down and killing lots of people. But the principles of applying electrical energy and using it and directing it and channeling it and being mindful of it, it's amazing. There's a lot relevant in there. What are you guys' thoughts before we kind of wind down on this?
I'd love to one day write my own book and squeeze as much of this as I can back in. You know, the terminology, the wording, perfect. You know, I'd love to try and push it back in because it has a place, I think.
I agree.
You know, I think it has a place.
It's a great way of driving up the workmanship and the quality. You know, when we talk about raising standards, this is raising standards.
If you were a professional electrician on the trade, trying to think ways that you could improve yourself, you could probably push that you work to the old principles of the original rules, and you can quote some of this stuff.
I'll tell you what I'm going to do. I'm going to write a railway standard, Dave. I'm going to write a railway standard, and in it, I'm going to use the word perfect. And in it, I'm going to quote the first edition of the wiring regulations where practicable. So that way it's a little bit educational. But John, what's your thoughts? Because you are a guru on past edition of the regs.
Yeah, I mean, I've got a certain small collection, shall I say, of these items. Yeah. But yeah, I mean, this is obviously, we just looked at first edition here, but if you look at even some of the others as well, it's amazing how much stuff is still in there that's been in there for like 50, 100 years or even more. And it's like people think all this stuff has just come about recently, but no, it hasn't. It's been there for most people's entire lifetime. And it's just a question of reading it, really. And if you look in there, you see all this stuff that has either been in there forever or sadly, a lot of stuff that was in there and is now disappeared and is no longer thought about, but it's still relevant.
There you go. Right, and on that bombshell, this has been a more interesting one. Thank you very much, everybody, for watching. Thank you very much, everybody, for listening. Make sure you look after yourselves and each other. Stay safe, and thanks a lot. Take care. Bye-bye.
Bye-bye.
Bye. But that's going to be really difficult to find.
We could put an appeal out for you, see what comes in.
We could do literally an advert that says, you know, every year a copy of the wiring regs is destroyed. You know, give JW a chance to rescue them all.